hello, Fruitport High School chemistry students. Mr. Kovalak coming at you today. We're making a video with some students. We have Logan and Colin and Sydney. And normally I make the video not wearing a mask because I'm the only one in the room, but we have a couple students nearby. And today's video is to show everybody that missed class on Thursday or Friday this week. We talked about our lab data. They're going to present their data so people that were absent can see this. So I'm going to turn the camera, and we have Logan and Colin and Sydney. And so we're going to talk about their lab data and learn from it. So I'll kind of MC for the side here. So who would like to tell us what we actually did in lab in the first half of the week? Like what was physically what you did? So who's going to explain that? Thanks, Logan.
Last week in lab, we measured different shapes of metals and various substances like copper and wood and aluminum, and we found their mass and the volume, and then we graphed it.
Good. And Sydney, how did we get the mass and the volume?
The mass and volume for the mass, we weighed it on a scale.
Good. We just
with
weighed
grams, and then for volume, if we couldn't find the length, width, and height, and multiplied that, we took a
what's called a graduated cylinder.
A graduated cylinder and put water in it, and then we looked at the tick mark, and then we wrote down the tick mark, and then we put the piece in it, and then how high it went, and then how high the tick mark, the water went after.
You did a great job.
After we put the piece in, then we would write that down and subtract it, and then we got the.
Good. Now you could have just said very simply water displacement, but you did a good job trying to explain water displacement. Good. All right. So this is your lab data. This is your data here, right, of 3 different materials. So how about you guys tell us about your board? How did the data show up? What do we got there?
For the data, we had to graph it on here and show the mass and volume. So we wrote it, we graphed it, and then we did a best fit line on each one.
Good. So which, in case I can't see the colors from there, what color or which line represents copper?
Copper is this first one right here, this orange one.
And keep going. What are the materials?
This green one, this middle one, and then wood's the brown one. That's the one.
All right. Good. And I don't know, Colin, let me get you involved here. What do all 3 lines seem to have in common?
They all start at 0, so this graph's proportional.
Yeah, they all start at 0, which means the graph is proportional. Good. And Colin, do these lines have positive slopes or negative slopes or?
They have positive slopes.
Yeah, they have positive slopes. Good. So an algebra teacher would be happy we got that. So, well, then why are the lines at different slopes?
The lines are at different slopes because each of the substances have different densities.
Good. Now, so let's talk about this one here. So over here we have a little, board kind of calculating it. So why don't you read us the slopes of your 3 materials, so people can see it. So point to them and kind of read off what the slopes are.
The slope of aluminum is 2.72 grams per milliliter. The slope of wood is 0.83 grams per milliliter, and the slope of copper is 10.562 grams per milliliter.
Good. And so we learned earlier this year that slope has units, so I'm really happy you put slope in with units because we have those. Now this units different on different labs and different graphs, certainly. The second thing we learned is that the slope always means something. And you kind of already hinted at it. What's the D word? What does the slope mean in this particular graph?
The slope in this graph represents the density of the different
The
materials.
density, yeah. So copper and aluminum and wood apparently have 3 different densities because we have 3 different slopes. And if you like visuals, you can look at the graph and see 3 different slopes. Good. I don't know if we didn't practice this. Anyone comfortable? Can anyone take that aluminum slope of 2.72 grams per milliliter and put it in a sentence form instead of a math form? We sometimes call those for every statements. Raise your hand. Who wants to do that? All right. Kyle, give it a try. Aluminum, what would the for every statement be for aluminum?
For every 1 milligram of aluminum, it weighs 2.7 grams, or 2.72 grams.
Good. Let's rephrase it because you said milligrams, but I think you meant milli something different.
Oh, milliliters.
Yes, do it again so it's nice and clean here.
So for every 1 milliliters of aluminum, you have 2.72 grams of aluminum.
That's perfect, right? Good. Now, this is true for any piece of aluminum. We have the same density because it's a comparison of the two ratios, grams and milliliters. Now, I know what the aluminum's supposed to be 2.70, like right exactly 2.7, and we're really close. And I know copper's supposed to be 8.9 grams per milliliter. So how come, I just happen to know those densities because I looked them up yesterday. How come we're close but not exactly on? Anyone want to explain why would we be close to having the right densities?
Error.
What do you mean, Sydney? Explain more.
So, because we're not all perfect, we sometimes make errors in our calculations, and even when we do the lab, sometimes we make errors and not everything's 100% correct.
Good. So I would say errors in calculations was not quite right because like punching numbers in the calculator, it's not this. But are there some limits to how accurate we're in the lab? Maybe because we're going too fast or the tools are a little bit not perfect. So yeah, so that would explain why we're close but not perfect. I think we did a good job. Okay, so I think now that we have the densities, I'd like you guys to do this. I'd like you to grab some markers. I'm going to zoom in here. I would like you to physically draw on each line a particle level diagram picture to show which is more dense and what it will look like in picture form. So do we have the markers close by? All right, so how about I try this? I'll try pausing this, which I've never tried. All right, so during the break, the rain has started. Hopefully that's not being picked up by the microphone too much with the storm outside. And so we have drawn some pictures. So Colin, why don't you point to the pictures and explain why you guys drew them the way you did?
So for each of these are just representations of the densities of the material. And that being said, you can tell that copper, having the most dots in the smallest space, would be the most dense, and that wood, with the largest circle with the least amount of dots in it, would be the least dense.
Good, so we can draw density based on how close together the particles are or how far apart the particles are, right?
Yep.
Now we've drawn particles of elements, compounds, and mixtures. We've drawn pictures of solid, liquid, and gas. And so we have some issues where it can get complicated if you try to do all of this. But certainly the closer together they are, the density can be arranged. And you guys will have to deal with that with the packet and the homework. Good. All right, the last thing I want you to do is you're supposed to memorize what's the density of water. Who remembers that?
The density of water is 1 gram per milliliter.
Oh, thank you. A lot of people just say 1, but you put units in that. So I would like, since slope is density and density is slope, I'd like you to draw one more line. Here's a blue marker, because like water's kind of blue. Where would the line for water go on here? So talk us through. What are you thinking, Logan?
The line for water, since it's a slope of 1, it would be a 1-to-1 ratio. So then we'd go to 30 and 30.
So 30 milliliters and 30 grams is right
Put a
there.
point right
Good.
there.
And maybe
skip over to 60.
60. Good. And Colin, go get a straight edge real quick. Go careful. Is that right? Okay. Good. And I think it's proportional. It should hit at 0, 0. So can we actually do that while it's tilted in the holder there? Good. Oh, and we're going to be so lucky. Let's go ahead and add. Do you have a little spot? Add in the legend. Add a little blue dot and put H2O or spell water, whatever you prefer. All right, you guys did a great job. You did a great job. So the last thing I want to point out here is that density. This goes into tomorrow's lesson. Density has things to do with sinking and floating. So when you actually put the aluminum in water, did it sink or did it float?
It sunk.
It sank. If you're more dense, you sink. And copper, did this also sink in the water? Now, you didn't put the wood in the water because we did length times with times height. But do you think the wood would sink or float in the water?
Float.
It would float because it is less dense than water, and things less dense will float. So, hey, quality job, guys. Thanks for doing things a little something out of the box. And, well, you guys get an A. Good job.